When solving algebraic equations, there's some things that I like to keep in mind that help me solve them. These things are true regardless of the algebraic equation, and they will make solving them much easier. First thing is, when we say solve for x, what we really mean is we mean find out a value that will make the equation true. So in other words, if we have an equation like 3x plus 2 equals 8. What we want to know is for what value of x is this true. That's really important when we're solving equations like this. You can probably look at this equation and figure out what x is equal to. However, we want to be able to solve it regardless of the equation. So solving for x just means to find out what x equals. We can then check it to see what it equals by putting the value back in. In this case, we know that x is going to be 2, so we can simply say that 3 times 2 plus 2, does that equal 8? That's our question mark. Is that true? Well, 6 plus 2 does indeed equal 8. Therefore, this is true. So solving for x means what is that value for x? In this case, our solution is just x equals 2. The second thing to keep in mind is like terms can only be combined with like terms. Now, most of you will remember 2x is a term. We can add a constant to that, so 2x plus 2. In this case, the 2x is a term and the 2 is a term. One is a numerical coefficient and a variable, and the 2 is a constant. We can only combine like with like. In other words, we can take 4 plus 2 and combine those to say they're equal to 6. We can take 2x plus 2x and combine them and say they equal 4x, but we can't say 2x plus 2 is equal to 4x. We can't put those two together. Next thing we need to keep in mind, operations completed on one side of the equal sign must be completed on the other side of the equal sign. Otherwise, they're not the same as. So if we think about that in a simple form, if we had 4 equals 4, we would think it was ridiculous to say that 4 plus 1 equals 4. However, we could say that 4 plus 1 equals 4 plus 1. So as long as we do the same thing to each side of the equal sign, we're fine. So 4 times 5 does equal 5 times 4. In both cases, we're multiplying, and these are the exact same at 20. So as long as we're doing the same thing to both sides of the equal sign, we maintain the equality, and we make sure that equals means the same as. They always stay the same. The fourth thing is equations are solved by isolating the variable using the inverse or opposite operation. So whenever we add something, 3 plus 2, the opposite of adding 2 would be to subtract 2. So if we take 3 plus 2 minus 2, we get 3. 3 times 2, the opposite of multiplying by 2 would be to divide by 2. So when we do these inverse operations, we're not actually changing what that side equals. It still equals 3. So 3 is still equal to 3 in both cases. So we want to make sure that we do these inverse operations. The fifth one is write equivalent equations going down the page until you isolate the variable. Whoops, I put that down twice. Going down the page until you isolate the variable. Let's have a look at what that looks like. In this case, let's say we want to do 3x plus 7 equals 28. So we want to get x by itself. That's the goal. So we're going to try to take these rules that are above, and we're going to try to follow these rules in order to get here. So our first step is we have two terms. We can't combine like with like. These are not the same. However, we can get x by itself by getting this term by itself. We want 3x by itself. To get 3x by itself, we have to get rid of the plus 7. So we're simply going to do an inverse to get rid of the plus 7. equals 28 minus 7. We've still maintained equality because what we've done to one side, we've done to the other. And 7 minus 7 is 0. So we don't write the 0, we just say 3x equals 21. Now a lot of students ask, do I need to write this step? No, it's not necessary if you can do it in your head, but if it helps you, write it. The next step is we have 3x. 3x means 3 times x. The inverse of multiplying is dividing. So we're going to divide both sides by 3. It's multiplied by 3. We want to divide by 3, which means we want to maintain equality. So we're going to divide both sides by 3. When we divide 3 by 3, 3 over 3 is equal to 1. So we now have 1 times x leaves us with x. And we have a 3 will divide into 3 once, and a 3 will divide into 21 7 times. So that tells us that x equals 7 over 1, which is 7. Now the last step, if you don't want to make any mistakes and you want to make sure you didn't make any, you want to just take this number and put it in and say, is it true? Is 3 times 7, putting the 7 in for our variable x up here, plus 7, does that actually equal 28? That's our question. We don't know. If that's true, then we've solved correctly. So 3 times 7 is 21 plus 7. And in this case, we're not making any changes to either side. We're just putting in the values and solving each side. Is that equal to 28? And 21 plus 7 is 28 equals 28. Therefore, we know that this is true, and we've proven it, so we know that our answer is true of x equals 7. I hope this helped you understand algebra a little better, and we'll continue on with some more videos. Thank you.